Okay, we're going to look at angles between vectors. We're going to achieve the calculation of an angle between a vector using the scalar product formula. Remember that A dot B equals magnitude A times magnitude B times cos theta. That will be given to you in your formula sheet. What won't be told to you in your formula sheet is the rearrangement of that. So if I write that back to front, magnitude B, magnitude A, magnitude B cos theta equals A dot B, I can then bring those two down and divide to give me cos theta equals A dot B equals magnitude A, magnitude B. Now what you'll be given in a formula sheet is that. What you won't be given is the rearrangement of it. You need to be able to do that yourself. Okay, let's try an example 1. Example 1 is we're going to calculate the angle theta between vectors P, which is equal to 3i plus 2j plus 5k, and Q, which is equal to 4i plus j plus 3k. Okay, so my first move then is to calculate this scalar product up here using the component form. So it's going to be P dot Q is going to be equal to, well, let's just see, well, the vector P in column vector form is going to be 3, 2, 5, and the vector Q is going to be 4, 1, 3. So P dot Q is 3 times 4 plus 2 times 1 plus 5 times 3. And that will give me 12 plus 2 plus 15, which is 29. Okay. Next move is to find the magnitudes. So the magnitude of P then is the square root of 3 squared plus 2 squared plus 5 squared. That's the square root of 9 plus 4 plus 25, and that's the square root of 38. Okay, I'm now going to find the magnitude of Q, and that's the square root of 4 squared plus 1 squared plus 3 squared. And that is equal to the square root of 16 plus 1 plus 9, and that is the square root of 26. Okay, so I'm now going to put it all together then. And I'll get cos theta. Let's put it in this context, P dot Q over magnitude P, magnitude Q. Cos theta equals, well, P dot Q, the scalar product, I want that out to be 29. So it's 29 over magnitude P root 38 times magnitude Q root 26. It's then theta equals cos inverse of 29 over root 38 times root 26. So just enter all of that into your calculator, making good use of these brackets, and to one decimal place you should get 22.7 degrees. Okay, let's try an example 2. Okay, let's try an example 2. Example 2, we're going to find the angle in between the vectors A, given in column vector form 1, 2, minus 1, and the vector B given by minus 2, 3, 1. Okay, so first of all, let's get A dot B, so that's 1 times minus 2, plus 2 times 3, plus minus 1 times 1, that's minus 2 plus 6 minus 1, and that's 3. Okay, let's now go after the magnitudes. So magnitude A, square root of 1 squared plus 2 squared plus minus 1 squared. That's the square root of 1 plus 4 plus 1, that's root 6, which can be simplified. Okay, magnitude B, that's the square root of minus 2 squared plus 3 squared plus 1 squared. That's the square root of 14, which cannot be simplified. Okay, let's now put it together. So it's going to be cos theta equals a dot b over magnitude a times magnitude b. A dot b up top is 3 over root 6 times root 14, and then theta equals cos inverse 3 over root 6 times root 14. Enter all that in the calculator into one decimal place, you should get 70.9 degrees. Final answer.